Good afternoon. Thank you all for coming. I would apologize that you're all missing sunny San Diego, but you're not. So going conference room to conference room is not so bad today. So we're really glad you made the trek over to the Marriott and to hear about how we're scaling Kubernetes at Google and Spotify and learning some of the pain points that we've had and tactics that we've taken along the way. Just to start, I'm Austin. I work in core infrastructure at Spotify. Our team is responsible for helping the 280 teams across Spotify with 1,500 engineers deploy 1,200 microservices many times every day. And this...
Thank you, Austin. And I'm Jago Macleod. I'm an engineering director at Google working on Kubernetes and GKE and have spent the last few years operating more clusters, but we're not going to share exactly that number. And the slide before, Austin talked about building the infra that powers your audio. And I extended that to say we build the infra that powers the infra that powers your audio. And this is a common theme we find, that there's a sort of a separation of roles of the team that manages the platform and the teams that build the applications that run on the platform. And this talk is largely targeted towards the platform managers or operators. There's something to learn for the application developers as well. But really this is about when you scale out across your organization, how to maintain some control over the platform that you're supporting. So we have a few goals for today. This was to keep ourselves focused. It's a big topic. So our goals today are to talk about why it's important to think beyond the steady state. And we'll define that and talk more about that in a minute. And the second is to talk about the real operational challenges. There's a saying that quantity has a quality all its own. And it really is true. Operating at scale carries some unique challenges that are not evident when you spin up a 3-node Kubernetes cluster. We're going to talk some about that. And then finally, we'll share some concrete learnings, lessons learned, what we think of as best practices and patterns that you can repeat. So it's important to qualify what we mean by steady state. So Kubernetes is itself about elasticity and reaction, being self-healing, self-scaling. So that's all within the requirements of the system and included within the steady state. So after you provision a cluster, you have a few nodes, you're running some workloads, it's scaling pods, it's replacing things that die. That's all expected behavior. It is, don't get me wrong, a marvel of modern engineering. It's incredible that it works as well as it does, but it's sort of expected for this talk. The components on the underlying platform in a steady state are assumed to be stable. You're not swapping them out at runtime. And so that platform is somewhat stable. And it's important to distinguish that even the high end of a predictable or mostly predictable curve is included within the steady state. Maybe you run a media outlet and you have a daily curve, or you run a game and peak users should be on the weekends, but actually they're on Monday morning, oddly. No one can figure out why. But even the peaks of Black Friday, whatever you can generally predict and be prepared for, those are included within the steady state. And interestingly, when we talk about scalability, we tend to over-focus on this steady state. How many nodes can a Kubernetes cluster scale to? 5,000. We've done other talks where we talk about scalability not being a number, but really a bunch of dimensions. And the dimension that we want to focus on today is really the dimension of time evolving over quarters and years. And we talk about that you do this until you're brushing up your resume to work somewhere else. So if folks see that over your shoulder, they should think, uh-oh. But this is supporting a system over multiple years, living with your past choices, understanding the trade-offs, and then living with those for years is an interesting area. And so we tend to overlook the operational challenges. It's not just about 5,000 nodes. It's what happens when you need to upgrade 5,000 nodes and it takes an hour to upgrade every node. That is, suddenly you realize that what works for 3 nodes is drastically different than for many, many nodes. So there's a laptop sticker, bumper sticker that says there is no cloud, it's just someone else's computer. I don't think this is actually well enough understood still today. It actually is one of the things that kind of annoys me about the term serverless. There is always a server running that code. It is occasionally, sometimes often, useful to hear what that computer says about running the thing that you'd like it to run. So it's not truly serverless, it's just somewhere else. And even someone else's computers, our computers in this case, fail. They fail all the time, you don't see it. GCE does magic live migration of VMs. Those of you who are pushing the boundaries do detect the infinitesimally small bit there, so kudos to you. But mostly it's invisible to end users. And Kubernetes, like we said, the expectation is that it will resolve many of these requirements for elasticity and self-healing. Zones, even regions, they go down. They will go down. We embrace that at Google. We understand we have an error budget. We understand that a zonal failure or a regional failure for internal services is expected to happen sometime in the next year, 2 years. It's going to happen. We build systems that assume that that will be true. So the core question for this session, the focus here, is how do you build a globally available service in a collection, on a collection of demonstrably demonstrated to have been unreliable regions and zones? And that is the question that you should drive to. You should have an understanding of that. And it will take time to evolve, but that should be the North Star. And you need to think beyond these steady states over quarters and years in order to get there. So we have 2 core takeaways that we wanted to focus on today. This is a giant topic. The 2 areas we wanted to talk about was automating the infrastructure upgrade and managing multi-cluster deployments. We take it as a given that if you have highly available systems, globally available services, that necessarily includes multiple clusters. I think multi-cluster will be a very crowded space in the Kubernetes community and vendor community over the next 2 to 3 years. So there are lots of choices, but think about your strategy and what you're trying to get out of it over time before you jump. Well, let's jump in. Okay, so this is the first part, the automating the cluster upgrades. Okay, this will take some explanation. At GK, we use a concept of soak time, which is essentially cluster days or cluster years that have accumulated as used by some end user. So a release candidate becomes available, the blue line, after an open source Kubernetes version is cut. And a few brave customers adopt it, they try it, they find a bug. Okay, we patch that in open source Kubernetes, we cut a new patch version, we make a new release candidate, it accumulates a little more soak time. And then maybe the 0.3, maybe the 0.4 release, it accumulates enough soak time to get over the first green line, which means that it can progress from our alpha channels or rapid release channel or alpha clusters into the GA or regular release channel. It is made available first, not auto upgraded to. It accumulates more soak time. Then it becomes the default for new cluster creation. And then it becomes the upgrade target. And we will auto upgrade many of the clusters in the fleet very carefully across multiple regions and zones. And so this is the idealized soak time accumulation of a version. In a perfect world, there would be exactly 3 release candidates. The 4th would be perfect. It would go out, it would go up, and then eventually the next quarterly version or minor release of Kubernetes would become available, and we would migrate you to, or you would migrate to, that next minor release. Sadly, the math is kind of against us. This is the lines of code of Kubernetes over time. There are a massive number of lines of code. Interesting spike here. And Kubernetes 1.5 was checking in generated code, which we quickly realized was not brilliant and stopped doing that. So good for us. But this was SIG auth's state of security slide from the contributor summit on Monday. And it's showing that there's just a tremendously growing number of lines of code. Interestingly, not included in this slide are all the other things that get packaged together in a distribution of Kubernetes by some vendor or yourself. So Core DNS or KubeDNS, maybe use Calico, maybe include Istio. There are all kinds of other add-ons, extensions, ecosystem stuff that you include in it. And so if we all would write all of this code which is completely bug-free and worked perfectly together, there would be really no issue. We would be back at the idealized version. But in practice, that's not what happens. And so this is an actual view of accumulating soak time for GKE release candidates over time. And we backport important security fixes and patch versions to older versions, those that are considered more stable in open source Kubernetes. And this includes the Kubernetes components themselves. There are all these add-ons. There may be an issue in a container runtime. There might be a base OS image. There are kernel regressions. This goes all the way down. And occasionally, the automated testing that's in place doesn't catch things in test. And so only running Elasticsearch at scale under these conditions with this kind of throughput manifests some issue. It's an issue for all Kubernetes users, but somebody discovers it. And so even older versions get patch releases fairly frequently. And you all, end users, also do things we didn't anticipate. It's really quite amazing what a creative group end users are. So all of that together, what I'm trying to drill into is that the frequency of upgrades, it's not once every 3 months. In practice, it's typically more than that to maintain a stable and secure environment. And we go through thought exercises at Google about scalability. And if we think about scaling 10x, you can almost see how the super effective engineer could work a little extra and solve a problem that's growing only 10x. But when you do the thought exercise with 100x, you think, oh, okay, we have to fundamentally assume that there's a different way of operating. So cluster upgrades are coming, and things that are frequent, you need to do, you just need to automate. Before we move on, I will point out that a very effective solution here is to assign a super sarcastic, kind of lazy but brilliant engineer to this task, to do a manual task once every week for 4 weeks in a row, and I promise they will automate that. They will die before they do it a 5th time. This has been super effective for me. I hope it is for you too. Okay, but there is some good news. The good news is that historically, we have been changing APIs fairly frequently over the last 5 years. The truth is adoption really outpaced production readiness in Kubernetes. I take this to mean that we created something very useful enough to assume that risk. But honestly, there has been risk. And it's not getting to a V1 API is not really about the quality of the code. The code is already very high quality. But it's about the assumptions, the backwards compatibility, the portability of your applications that you write on top, because the conformance tests can only exist for those APIs that have moved to a V1 API. So Brian Grant put this diagram together in 2018, and those things that are red were not V1 APIs. We invested pretty heavily this year in bringing forward those APIs that had stalled out at beta, and only a couple left. I'm not sure why we didn't highlight this, but Ingress, you can see in the upper right-hand corner, still has a couple steps to go, and cronjob has been quite stubborn to move to GA. So those are the 2 remaining ones. But the point here is that looking backwards in time, I typically talk to customers who are still on 1.9 and they're holding on to 1.9 because they were burned in the 1.7 to 1.8 upgrade because we moved an annotation to a field and we broke a bunch of things. So I'm just encouraging you not to base your upgrade policy on 2 years ago information. Look forward and understand that this is over multiple years, and to develop a strategy that's looking forward. Okay, so to summarize the good news, just about all APIs are GA, or there's a plan to get to GA in the next quarter. And the other interesting development is community support around this concept of supporting 4 instead of 3 minor releases of Kubernetes, so 12 months. So we find that retail customers, for example, don't upgrade during Q4, very important, and then they do sort of clustered upgrades at the beginning of the year, and this is a pattern I would expect to move forward. The other we'll move on. Okay, so upgrades, very frequent. If it's very frequent, make it automated. Find some way to automate it. Version 1 is just about done. And final point, being too early or too late, meaning adopting a .0 release, is generally not encouraged. We found a couple years ago, before we had release channels, that our newest customers were the ones that looked at the numbers and said the biggest number, it must be the best one. And they found all the bugs in all of Kubernetes, which was not very fair to them. So at Google, we have adopted a release channel model where there's a rapid, a regular, and a stable release channel. And just as you would find with other projects, we promote across those boundaries. Watch the release notes and pay attention. You may be using some feature of Kubernetes depending on some beta API that's being deprecated. You can subscribe in your Slack channel to the RSS feed. That seems to be a good pattern, but pay attention. So we have a concept at Google of haunted graveyards. And haunted graveyards are exactly what it sounds like. It's a thing that you're scared of, so you avoid it. You walk all the way around instead of going through it. And those things, everyone has 1 or 2 of these things in their system. They're the things that burned you last time. Anytime anyone touches that thing, it breaks. We just do whatever we have to do. Some smells that might mean you have haunted graveyards is if you have a really strong front-end team and a back-end team that's just getting started. And the front-end team is doing all kinds of crazy things to get around not having the right API in the back-end. This is an example of a haunted graveyard. So upgrades are often a haunted graveyard. Just if something is scary, do it all the time. Do it 3 times a week for the next 4 weeks until it's completely natural. And Austin's going to talk about this more, but productize and limit the customization of your own end users to avoid fragmentation and give yourself some freedom to evolve the platform. All of this is leading up to cultural changes, and the cultural change is really dynamic stability. The fact that smaller releases that are more granular, easy to roll back, they tend to have smaller incidents associated with them. And many of the customers I talk to who are modernizing to their environments and so on, they're in this state where it takes 2 years to migrate to the cloud because they've gotten to this static stability. Nobody touches anything and it doesn't break. But this actually introduces additional risk of especially security vulnerabilities, but also not being able to give your developers, your end users, the right functionality at the right time. So really try to drive this cultural change within your organizations and it will pay off. Last point on this slide is to get your observability right. Small changes, it really is critical to instrument and have good indication of health so that when you make these small changes, you can correlate a change to this thing resulted in an increase in latency in that thing. And that's really important. Okay, so we're going to go through the next few slides really fast. This is a very deep topic, but I wanted to make sure to put in some very concrete guidance. So what is the simplest thing you can possibly do to automate your upgrades is just enable node auto upgrade and pick the rapid or the regular release channel. It will happen over time. Eventually, you have one cluster, something will happen to your one cluster. So if you want to get some guardrails around that, you can create a canary cluster, and we publish what order we're going to roll out our changes across Google Cloud, day 1, day 2, day 3, day 4, regions and zones, and you can create a canary cluster in a day 1 region. Our upgrades will land there first. You have implemented a Stackdriver uptime check, and you can see that something has gone wrong in your canary cluster, and then you use the maintenance windows to delay the upgrade to your production clusters. This is very, very little work on your part, but it gives you just-in-time information about upcoming changes to the platform. Also, make sure to automate the alerts too, depending on yourself to remember to check the canary cluster every certain day of the week is not, from experience, that doesn't work well. Okay, then you're gonna get more advanced. And this is where we're gonna get into some very concrete stuff that Spotify has done against this background. So the first topic here is to embrace the declarative configuration of all the things. Okay, so configuration as data. This is subtly but meaningfully different than configuration as code. Code implies that there is some conditional logic, maybe even a Turing complete language that you're running against your config template. This is almost always non-deterministic and will result in very strange outcomes. So thinking of this, even if your implementation has some of that, thinking of configuration as data is really important. Then you check that data into Git, and you have a source of truth of what was true at that point in time. Terraform is great if you're going to configure and automate cluster creation in addition to automating your upgrades. Please read Terraform Up and Running or some similar book. It is a very powerful tool, and you can delete clusters by accident. I've seen it happen. It's scary, but it's powerful, and if used correctly, it's great. Use Kustomize or something that does configuration overlay instead of this Turing complete language to parse and modify your template. And then one project that's coming along is Config Connector to use Kubernetes resource model everywhere. So just like you create a new pod, you would create a new Cloud SQL or a load balancer and so on. So you can use the same tools that you manage your Kubernetes resources to manage the infrastructure itself. Okay, quick note on large node pools. 5,000 nodes, one node at a time, an hour. It can take a week or more to upgrade your node pool. This is usually completely unacceptable. So a couple patterns that work well. One is surge upgrades where you can specify up to 20 nodes at a time. And the other is create a new node pool and then shift traffic to it instead of doing a rolling update to the node pool. Pro tip, it's usually safe to skip a version number for node pools. So if you end up a few versions behind, upgrade your control plane 2 versions, and then you can skip usually the interim version of a node pool. That generally works. We see lots of customers do that. If you have a very large node pool, that can save a lot of time and get you caught up more quickly. And take some time. It's Q4. No one works that hard during Q4. Please take some time and come up with a global deployment strategy. Figure out how many regions you want to be in, how many zones. It will take you quarters to get there, but just having that roadmap of where you're trying to go will truly help. So understand the implications of multiple clusters, high availability across those clusters, how you're going to shard users or use those multiple clusters, how you do failover, disaster recovery, and special note on networking. As a not networking expert before this, networking gets complicated quickly, so don't leave that to the end and then say, uh-oh. So once you get to this advanced stage, you need to do something to simplify the experience for your end users. And Spotify has done some amazing work to simplify the use for their end users, the customers of their platform that they've built. And Austin's going to talk some about that specifically. Thanks.
Thanks, Jago. Oh, you get a Speak clap, very good. So as Jago said, we've been doing a lot of work to simplify that deployment process across many of these clusters that we're creating. So jumping in here to our second takeaway, create multi-tenant ephemeral clusters across regions and manage cross-cluster deployments. So let's unpack that. Starting with some of the sort of foundational challenges. Independent of what's possible for your scale and what clusters will support, you don't want one cluster. One cluster is one single point of failure. We've listed a couple things here that can happen. I'll certainly call out the last one as Jago mentioned it. And it was actually a keynote at KubeCon Europe around having Terraform blow up and delete clusters. That does happen. And if you only have one, that's not good. And second, and this one may be obvious, but as you start to have more and more clusters, any difference in configuration of those clusters becomes really bad. At 2 a.m. when your room is completely dark except for your laptop screen and you're trying to figure out why everything is not working and you have differences in your clusters, that's a bad place to be. So automate that as much as possible, but how do you do that as you continue to scale and have more and more clusters? So perhaps you're bought in on those challenges. But before we jump to solutions, there's a couple of learnings we wanted to call out. First, 99% of the time, developers don't actually care how many clusters there are or where they're deploying it to until they have some sort of problem. So make that common use case easy. Make it easy to deploy, make it automated to deploy to whichever cluster makes sense. And don't make a developer deal with that every single time. But give them the tools to be able to understand where a workload is or where a problem's occurring. And secondly, and Jago already called this out, but network is complex. And it's really, really hard to change once you're at scale. And this is a pain point that we have and are working through, but it is definitely something, if you have the flexibility and freedom to deal with now, definitely do it. Because you will not want to deal with that later. Awesome. So to walk you through a little bit of a story, here is a very simplified version of our CICD stack. So there's a build system, it creates an artifact. That artifact is then passed to Tugboat, which is a very simple API we use to manage deployments. If you've seen other Spotify talks, you may have heard of this. It essentially is what was used to actually migrate us to Kubernetes. A number of talks on that you can find or even see this week. Tugboat then passes to Spinnaker, which deploys the final artifact to GKE. But what I told you is that you need something that actually manages which cluster to deploy to. Enter Compass. So Compass is a tool that's been built. It's very similar, if you actually attended Airbnb's talk yesterday, to how they manage deployment across clusters, probably something that should be open source somewhere. But Compass essentially manages where a particular workload is deployed. So just to sort of land that a step further, this is a deployment.yaml file, which is, again, YAML. If we didn't show YAML, we'd probably get booed out of here. This is what talks to Tugboat. So here you see a simple file that I'll break down. This bit here specifies where you'd like a service deployed. So again, this is what helped us with our Kubernetes migration, something you may have seen in the past. This here allows developers to specify where they'd like a service deployed to one or many regions in the ecosystem. Remember I said many multi-tenant clusters, but notice we're not exposing that detail to all developers all the time. We're only talking to them in the language they care about, which is which regions do you want to deploy to? You care about reliability, you care about performance. Here's a variable you can impact. And lastly, this is where a developer can actually define how many replicas they want per region. So how many clusters in a specific region they'd like a service deployed to. And that's it. That's what a developer has to do to hand over deployment to the infrastructure for it to be federated out across clusters. Then there's a lot of deployments, and things can get a little bit messy. So Compass manages that. Compass abstracts and manages which cluster a service is deployed to based on different algorithms. And one important thing to call out is having it at this abstraction level allows that algorithm to change. So you can start by having random cluster deployment to any cluster that makes sense, and then you can get smarter and smarter over time, choosing clusters based on pod headspace or something else. But as you know, abstractions are only good until they break and until you're in that dark room and it's 2 a.m. and things aren't working. So for that, we provide a couple of different tools for observing service state across clusters and allowing developers to quickly get in the right context. So what I mean by that is if a service is deployed in a particular region, the context for that a developer doesn't have out of the box because you managed which cluster to deploy to. So here are a couple of visualizations from our developer portal called Backstage. At the top, you'll see a snapshot of a mock service's current deployment across regions with an accompanying number of pods in each region. So a simple visualization so they sort of have the conceptual model for where they've been deployed. At the bottom, you see a bit more detail for each pod, including its current state and links into the Cloud Console so they can reason more deeply about a particular pod. This saves developers a ton of time and avoids them having to manually reason about where something went wrong, and as I mentioned, to get into that context. So that seems great. There are other techniques beyond what we did here. These are some things that were looked at. You'll see, a very simple answer is that can potentially lead to over-provisioning, which is maybe something you don't care about at all, is deploying every service to every cluster and just sort of assuming things will be fine. That is not something that would work for us. Second, there's Kubernetes Cluster Federation, again, something we didn't look at. I included the concept diagram on the right to show sort of the complication there. We, again, aimed for simplification as much as possible, and is why we moved away. So lastly, building on those alternatives, these are a couple of things just to think about as you're yes, thinking about multiple clusters and deployments, but even as you're thinking about rollouts and in particular cluster upgrades, as Jago said. Start simple. Don't over-engineer your clusters and roll out machinery, something like Compass, in one big bang. Like that is never a good idea. And highly related, always be weary of introducing any complexity in what you decide to build. If your company is anything like Spotify, new engineers will be there, different engineers will be trying to understand systems, and somebody who doesn't understand it or didn't build it should be able to reason about it and understand it, or it is too complex. So to recap, our two key takeaways. When operating Kubernetes at scale, think beyond steady states, and in particular, automate your cluster upgrades and manage multi-cluster deployments in a simple way. And with that, we'll go to infinity and beyond. You were definitely not getting out of here without a Buzz Lightyear, Jeff. Any questions? And actually, we're basically at time, so do you want to just do questions outside?
We have time for 2 short questions.
Okay.
Anyone? Right here.
So in terms of not letting the developers know where the clusters are deployed, for development use cases, actually they do want to know where they deploy, they want to debug it. So do you handle that case differently, or do you just part of the same?
So they can totally see where they are. Oh, sorry. So the question was for development use cases, how do developers see where things have been deployed to be able to debug? They absolutely can. And actually what we showed in the console, the visualizations there, they actually click into the pods and allow you to see them up front and center. We've just provided a light abstraction over that to make it easier to get into that context. So yes, that is 100% available to people. Just by default, we don't put that front and center, and they can get all the commands generated to them to kubectl into the right place.
If there are 2 or 3 services that depend on being co-located,
Yes, so that is also supported. Basically, you can specify at creation time. It's not something we included here, but that is a feature of Compass that allows you to have a few services co-located.
One more question. Anyone? Over there.
Yeah.
The question was about surge upgrades and how big a set can you upgrade. One of our very first customers to adopt this before it was made public and beta used this at the 11th hour before a big launch and upgraded a large cluster. And maybe Kobe's here. He told me that this happened. He said, "Oh, it worked. It was 2,000 node cluster." And I said, "Well, how many did they do at a time?" And he said, "All of them." I would not recommend that, but so I think depending on how many nodes you have and how much overhead there is, And cost is a concern too, right? You're going to create 2,000 new nodes and then migrate traffic to it. So there's a balance there. Customer controls how many at a time. I think 20 is the exposed current limit at a time, but we're open to feedback on how many at a time. Please not 2,000 at a time.
Good. Thanks again, Austin and Jago, for the presentation.